This is SpaceTime, Series 29, Episode 3, for broadcast on the 7th of January 2026. Coming up on SpaceTime, the ancient supernova, which may hold a key to the universe's mysterious dark matter, the long hypothesized sterile neutrino finally ruled out, at least almost, and China fails in its latest attempt to develop a reusable rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers studying a gravitationally lensed supernova may be a step closer to cracking one of the great secrets of dark energy, that mysterious force believed to be causing the universe's accelerated expansion rate. Dark energy makes up around 68% of the universe's total mass energy budget, but its exact nature is unknown, as is its influence on the evolution and ultimate fate of the cosmos. Scientists know it's caused an accelerated expansion of the universe ever since the Big Bang 13.8 billion years ago. But some more recent studies are now suggesting that dark energy's expansion rate is slowing down, and may even be reversing. Dark energy is important for determining the universe's ultimate fate. Right now, there are four possible outcomes. Either the rate of expansion will slow down and eventually reverse, resulting in gravity becoming the dominant force in the universe. That'll cause the universe to eventually start to contract again, ultimately ending in everything coming together again in a big crunch. The second alternative is a steady state, in which the accelerated expansion of the universe due to dark energy peters out, and the universe reaches a sort of steady equilibrium, looking much the way it does now. The third option is the big freeze. That's where the universe's accelerated expansion due to dark energy continues. Eventually, all the galaxies will be so far apart from each other, they'll disappear from view beyond the cosmic horizon, leaving the universe looking very cold, dark, and empty. The fourth possibility, and personally I think the most frightening, is that dark energy's power will increase, causing the accelerated expansion to become even more extreme. Ultimately, not only will other galaxies disappear from our view, but so too will neighbouring stars in our own galaxy. And after that, star systems themselves might be torn apart. And the ultimate expression of all that could well be on the subatomic scale, where objects are ripped apart into their constituent atoms. And even atoms are torn apart into their constituent nuclei and surrounding electrons. And theoretically, it could even see the quarks and gluons inside protons and neutrons also being torn apart. And this ultimate fate for the universe is known as the Big Rip. Now, astronomers observing a unique exploding star that went supernova some 10 billion light-years away, and hence 10 billion years ago, may provide some new clues. A report in the journal Astrophysical Letters says light from this incredibly bright event, known as a superluminous supernova, was bent and magnified by the gravity of a foreground galaxy to make it appear even brighter. One of the study's authors, Jacob Wise from John Moores University, says no one's ever found a supernova quite like this one before, and the nature of the system means it may be able to help solve some of the big problems of astrophysics, such as the nature of dark energy, the force driving the expansion of the universe. The lensing galaxy is in direct line of sight between the supernova, catalogued as SN 2025 WNY, and the Earth. And the manner in which its gravity is affecting light from the supernova as it travels towards our viewpoint is key to the puzzle. You see, light from this distant supernova is being split into multiple images. And when light is lensed, the different paths the light follows to get to Earth don't necessarily all travel over the same distance. So, light moving along different paths takes variable amounts of time to reach us. In the case of a supernova that shines for months on end, it means that we can see the different images of the same source all together at the same time. But each one is probing a different time in the supernova's evolution. Wise says what's exciting about that is that the amount of time difference between different images depends on the expansion rate of the universe. He now plans to measure these time differences precisely in order to determine how fast the universe is expanding, the so-called Hubble constant. Different ways of measuring that rate are giving different results, a problem known as Hubble tension. Measurements of the cosmic microwave background radiation, that's the afterglow of the Big Bang, recorded when the universe cooled enough for the first atoms to form, some 380,000 years after the Big Bang, suggest the universe is expanding at a rate of somewhere between 67 and 68 kilometers per second per megaparsec. But telescope observations by Hubble of the expansion, based on measurements of the nearby universe, looking at stars used as cosmic distance ladders like Cepheid variables and Type 1a supernovae, suggest an expansion rate more like between 70 and 76 kilometers per second per megaparsec. Wise says studies of lens supernovae like this one could indicate which of these two numbers for the Hubble constant is the more accurate.
What we have discovered is a supernova that is over 10 billion light years away, with a galaxy in the foreground. That means that it has been gravitationally lensed. And so instead of seeing just one image of the supernova, the light has been bent so that we actually see 3 or even more images. What's significant about that is that the light from each image is getting to us with a different travel time. So with that, we can use that to measure quite accurately the expansion of the universe. At first, I didn't believe that what I was seeing was real. I thought my eyes were just blurry. I basically rubbed my eyes and then it was still there. And so then I thought, oh, this is probably just an artifact on the telescope. Maybe there was high winds and it wobbled. But then I took a look at the data that we'd gotten 2 weeks previous and it was still there. And so then that really convinced me this is actually real. And so I immediately notified my collaborators in Stockholm, and they noticed the wider astronomical community that night that we had actually found this. This is the first time that this has been seen with what we call seeing limited ground-based observations. So that means that you don't need a space telescope or what we call adaptive optics to actually resolve the individual images. So this is almost like a proof of concept that this can be done with even mid-range telescopes. So the feeling of that was just sheer disbelief that I'd found this. This has only been seen less than 10 times in the entire history of astronomy. So since we found this, we've had every single major observatory in the entire Northern Hemisphere, and Hubble and James Webb looking at this thing, but the LT discovered it first. Just being involved in this sort of magnitude of a discovery is amazing, and it's really pushing me to stay in this field and get a postdoc. Kind of made me realize, like, this is why I'm doing this. Like, this is amazing. I still don't really believe it. It's taken a while to sink in.
That's Jacob Wise from John Moores University. And this is SpaceTime. Still to come, physicists finally rule out the existence of the long-hypothesized sterile neutrino. Well, almost. And China fails in its latest attempt to develop a reusable rocket. All that and more still to come on SpaceTime. After collecting and analysing data for more than a decade, scientists have finally debunked the long-held hypothesis about a mysterious particle called the sterile neutrino. Their findings, reported in the journal Nature, come from the Micro BooNE, or Micro Boosted Neutrino experiment at the United States Department of Energy's Fermi National Accelerator Laboratory in Illinois, Fermilab. Using a powerful liquid argon detector and data from 2 neutrino beams, researchers were able to rule out the existence of a single sterile neutrino with some 95% certainty. One of the study's authors, Andrew Masbaum from Rutgers University, says the results represent a key turning point in physics. He says scientists can now rule out a prime suspect, but that doesn't quite solve the mystery. Neutrinos are incredibly weakly interacting subatomic particles. In fact, they're so weakly interacting, there are literally billions of them passing through you right now, and you don't even notice them. They're created in powerful environments, like the cores of stars, exploding stars known as supernovae, and in nuclear reactors. The standard model of particle physics, the cornerstone of our understanding of the universe, states that there are 3 types of neutrinos: electron neutrinos, muon neutrinos, and tau neutrinos. And these different particles, known as flavors, can change from one to another, a process called oscillation. So, an electron neutrino may leave the core of the Sun, but by the time it reaches detectors on Earth, it may have converted into a muon or tau neutrino. The problem is, in past experiments, researchers saw neutrinos that appeared to change in ways that didn't fit the standard model. And to explain this, they proposed a fourth type, a sterile neutrino. And unlike the others, it would be more difficult to detect because it wouldn't interact with matter at all, except through gravity. Micro BooNE scientists tested this idea by observing neutrinos from two different beams and measuring how they oscillate. Now, after 10 years of data collection and analysis, the authors found no sign of sterile neutrinos, thereby closing the door on one of the most popular explanations for strange neutrino behaviour. Masbaum says getting these uncertainties right is crucial because it allows scientists to make strong, reliable statements about what their data is really showing. And this is important because it rules out a major theory about new physics. See, the standard model can't explain everything. It doesn't explain dark matter or dark energy or gravity for that matter. So scientists have long been searching for clues that go beyond the standard model. And eliminating one possibility, the sterile neutrino, helps them focus their search on other ideas which could eventually lead to breakthroughs in a better understanding of the universe. This is SpaceTime. Still to come, China fails in its latest attempt to develop a reusable rocket. And later in the science report, did you know that your adult toys may be spying on you? All that and more still to come on SpaceTime. China's new reusable Long March 12A rocket has failed on its maiden flight. The mission blasted into space from the Zhuquan Satellite Launch Center in Inner Mongolia. The rocket's first and second stages both performed as planned during the ascent to space, with the second stage successfully reaching orbit. However, the first stage, which was designed to return to Earth, landing vertically at a designated recovery site in Gansu province, failed during the return. It's a major setback for China's space industry. Beijing striving to develop a fleet of reusable rockets similar to SpaceX's Falcon 9, Starship and Starship Super Heavy, and Blue Origin's New Shepard and New Glenn rockets, all of which are designed for reuse. Having reusable rockets lowers launch costs, it improves efficiency, and can increase the frequency of space flights. The 70.4-metre tall Long March 12A is the largest rocket China's ever built, and it was designed to carry over 6 tons into low Earth orbit. Last month, the Chinese commercial space company Landspace launched its own reusable rocket, the ZQ-3, also from Zhuquan. It also managed to reach orbit, but its first stage booster also failed during its return to Earth. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists say that around 70% of the world's population may experience rapid rates of change in temperature and rainfall extremes over the next 2 decades if we fail to cut carbon emissions fast enough. A report in the journal Nature Geoscience examined projected rates of change in temperature and rainfall extremes over the next 2 decades using large ensembles of climate model simulations, also finding deep and rapid cuts to emissions could reduce this percentage from 70% down to around 20%. Without these cuts, large parts of the tropics and subtropics, encompassing around 70% of the world's population, are expected to see rapid changes in temperature and rainfall over the next 20 years. While northern latitudes, southern and eastern Asia and equatorial Africa are expected to see rapid changes in rainfall. Scientists have estimated the numbers of 2 endangered mammals on Australia's east coast, koalas and southern greater gliders living in the Illawarra range of New South Wales. The findings, reported in the Journal of Australian Mammalogy, used thermal drones to survey 47 sites in the region, finding just 56 koalas and 127 gliders over a total area of 1,175 hectares. The authors calculated the average density of koalas in the region was just 0.13 per hectare, and glider density was just 0.17 per hectare. The scientists say the density information is needed to track further changes in these highly endangered populations. It's been revealed that the US government keeps track of hospital emergency room records for patients who've come in for treatment after getting items stuck in their rectums. The American Journal of Emergency Medicine found that between 2012 and 2021, an average of 38,948 people each year were hospitalised with foreign objects inserted where the sun don't shine. The average patient with this, shall we say, malady was aged 43 and 78% were male. And it's actually not a laughing matter. 40% of patients needed to be admitted to hospital. The data is being compiled by the United States Consumer Product Safety Commission. It found that of the various items removed, 55.4% were adult toys. Other items which people seem to accidentally fall onto include shampoo bottles, baseballs, turkey basters, uncooked pasta, eggs, doggy chew toys, doorknobs, marbles, rocks, flashlights, light globes, battens, screws, nails, bottles, and in one case, a full-sized pumpkin spice-scented Yankee candle. In 2023, the Visual Journal of Emergency Surgery published a case study about an Iranian man who needed emergency surgery after he accidentally fell onto a large deodorant canister, which had somehow travelled all the way up into his digestive tract. Doctors say the problem then is how do you get it out? Because with things that are really big, you can't just reach up there and grab them and then pull them out. That's because the suction becomes a vacuum and pulls it back up in there again. And before we go, there are new warnings today that if your adult toys are capable of being connected to the internet, they may be spying on you. It seems that app-connected adult toys could be collecting highly sensitive data, impacting your digital privacy, no pun intended. Well, maybe just a little. These app-connected devices could be collecting data on your playtime behaviour, your preferences, your usage frequency, your intensity settings, as well as your other special interest activities. They could also be gathering data on your location and IP address. Now, most companies that collect data will claim they're doing it to improve their products. But that customer information is often also passed on to data brokers, who will then sell it to anyone who wants it, including the government, private investigators, advertisers, and even your ex. With the details, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
Well, it's a little bit like I was watching the movie The Running Man, the 2025 version, and in one particular scene, the hero goes into a store. He knows the proprietor of the store, and there are these old cathode ray tubes, televisions, cathode ray, CRT televisions, and the store owner said, look, those are very popular because these TVs are not watching you back. And we do know that Vizio, which is a big TV brand in the US that is not really well known in Australia, but big in the US, it's reported they make more money from the data that is gathered on what you're watching and the apps you're downloading and the things you're doing than they make from actually selling the televisions. And this ACR, this automatic content recognition setting that you can get on the major TVs and turn it off, is doing the same thing. Those devices are capturing data about you and then they're on selling them. And when you click the I agree button, you are unknowingly giving them permission to do that. So if this is stretched, well, it would just be the latest device that would be connected to an app of some sort and will be not just collecting the data for your benefit so that you can data mine yourself, but then they're taking that information, even if they are anonymizing it, but they're taking that information, putting it into some sort of database, having some sort of aggregate information out of that, and then on-selling it to people who are wanting to either know which particular lubricants are good or which substances may intensify certain feelings. And I mean, look, bring on the battery-operated devices that are not connected to the internet. I think those are going to, in the next few years, also become quite a popular thing as people decide that they don't want.
TVs are already spying on you, and I think my remote control can listen to what I'm saying too. It's got a microphone button there, which means it's got the ability to spy on me.
Yeah, well, I mean, in theory, these things could be hacked into, and then your conversations are being listened to. Televisions, over the past 20 years, there was a time when they all had Skype compatibility and they had a camera in them. But you go and have a look these days, all those cameras have been stripped out. And that's obviously because TVs are being hacked into. And then people were watching you Big Brother style through the television, the camera in your television. So the big problem of technology is securing it. And given the fact that even the vaunted and incredible Apple is forever putting out updates, every month or two or three, which are closing massive security vulnerabilities that can allow an attacker to effectively get full access to your phone and then use it to listen and spy on you, and which has been done by certain countries against their local dissidents. Well, the biggest problem with technology is keeping it secure.
That's Alex Zaharov-Reutt from techadvice.life. And this is SpaceTime. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.